Okay, so welcome everyone. Today I'm going to talk you through serverless PHP and something that I'll show you today, which I think is quite interesting, is how we can use async PHP on Alexa. I'm Chris Bell. Probably most of you might not know me. I'm helping out Tom. I'm now the co-organizer for Leeds PHP. I also work for Sky. I've been at Sky for 4 years now. I work for primarily. I'm working on Sky Sports related products. I'm the tech lead for Sky Sport Deutschland. So the program for today will largely cover four key topics. The first one being serverless. Then we'll talk about Alexa, what it is, how we can get it to work. We'll also touch on how we can use PHP in the context of both serverless and Alexa, and how we can utilize asynchronous PHP to our advantage. And I'll also briefly cover the serverless framework, which I think is really cool. So we'll start by covering serverless architecture. So when we talk about serverless architecture, we're generally talking about FaaS, so functions as a service. It's the idea of running a single function within the cloud. But does it mean there's no service? Surely that's what serverless is. Well, it's not quite like that. It just means that the servers that these functions run on aren't really yours to manage or maintain, which in a way sounds pretty good actually. One really good thing about serverless functions as a service is the benefit you get from auto scaling. So you no longer have to care about how your apps are going to scale. It's just done for you, and that I think is really appealing. It also begs the question, well, if we've got no servers to manage now, do we need an ops team? So it's an interesting area. One of the key premises around functions as a service is the cost benefit it can actually give you. So I think previously most of us would be accustomed to, I don't know, paying for time over a month period, something like that. In a serverless architecture, instead, you're actually paying for the execution time of your functions. That's quite a key difference to probably how most of us have written code before. It's well suited as well for microservices. So when we're talking about microservices, we're generally talking about small, loosely coupled services, and that's what functions as a service kind of fits that mold. There's already a number of major players out there that provide this capability. They'll include Windows as a function, IBM OpenWhisk, Google Cloud Function, and also probably one of the most popular ones, which I'll be talking a bit more about today, which is AWS Lambda. But I'd like to just show you this quote, or should I say tweet, that got a lot of retweets and likes last month. The next time you try use the word serverless, just remember it's like calling takeout kitchenless. Yeah. So the point there is, just because it's serverless doesn't mean there aren't any servers. But today I'll be focusing more on AWS Lambda. So I'm just going to give you a bit of an overview about how we might configure AWS Lambda. If you haven't used it before, this will probably be more beneficial to you. So AWS Lambda has an interface that you have to use, or you can use, to upload your functions and also configure it. So in this example on the screen right now, you can clearly see there's the possibility to upload our function contained within a zip archive. The other key thing to note on this UI is the triggers tab. It's important to bear in mind that functions themselves don't do anything. They need something to actually trigger them. So that could be, for example, an event where, say, in AWS land, that could be an upload that's happened on S3, or it could be your DynamoDB has updated, or even in our example, an Alexa request has come in, and we want this Lambda to be able to respond to that. On the configuration screen, the two key things to note there is the runtime. I think, as of last time I checked it, there's 4 key runtimes that you can use. Node.js, Java, Python, I think there was C# as well. There's obviously a big elephant in the room there, that there's no PHP, which you'll find out a bit more about later. And the handler is also quite important. So that's telling us that in the handler module, the next bus function is the thing that these events are going to be piled into. So that's the thing. It's, I guess, the entry point for the function. And then, the monitoring tab. This is what it looks like. It's just nice and simple. I'm pretty sure it's largely powered by the logs that you get in CloudWatch. But what does a serverless function look like? It sounds pretty scary. It sounds mysterious. This is it. This is it in its simplest form. Anyone in this room could do this, blindfolded. I guess the key thing to point out there is the third parameter in the handler. That's the thing that you'll use to be able to then pass back your message. So that could easily be replaced by hello world, or so where it says some success message, that's your hello world equivalent, basically. But to do all that sort of stuff, it's a little bit clunky if you're going via the interface. You can imagine the pain that you have to go through to get your code up into AWS Lambda. So that's write your code, do your tests, then work out which files you want to put into a zip, then put it in the zip, then go into that UI and upload your zip. And yeah, it's pretty laborious. You can get around that by using the AWS CLI, but actually I prefer to use the serverless framework. The serverless framework is there to abstract away the provider complexity. So, you know how we said that actually AWS Lambda isn't the only player in the market? Well, if you made use of the serverless framework, you wouldn't have to then relearn how to use the CLI for Google Cloud, or relearn how to use the CLI for Azure, for example. You just have this one common API. And this is what it is in its simplest format. So the config we've got on the left there, that's your serverless.yaml. You can see we specify which provider we want with a little bit of config. We also define what files we want in this zip archive and what files we don't. And I really like that because it just makes that whole archiving process so smooth. And then on the right-hand side, 3 important functions that I often use. So one, to test your serverless function locally. The next one to deploy it. And then the last one to actually test it once more, but remotely. So that's actually in the cloud. another important thing as well with the serverless framework, you can actually get templates, predefined templates. So out the box, you can install them for your runtime for a provider. It's really handy to get up and running quickly. So the next thing we'll talk about is Alexa and how that kind of fits into all of this. I'm guessing most of you have seen the adverts around Christmas for the Echo Dot, the little device that's at the front here. It's the quote, intelligent personal assistant. So it will tell you jokes, it will read the news to you, it will turn on your lights, that sort of thing. It's pretty fun to play around with. I'll just give you a little bit of, well, I guess the core vocab for Alexa. So the first one being a skill. So a skill is what I'd consider as being like an app. So it's an app for Alexa. I can build an app or a skill. And I'll be showing you later a skill that I've built to bring us back bus timetables. The intent is a particular action that that skill may perform. A skill can perform multiple intents, but in the example that I'll show you later, it's very bare bones. We're just using a single intent. And utterance is literally the thing that people utter. So it's the phrasing. So again, there's some UI for the Alexa side of things when you start to configure that up. It's not very interesting. So I'll normally show you this screen, which is somewhat more interesting. The other screen that I haven't included there is you do have the ability to map the intents to an utterance. So you can say that when a user says this, I want the skill to do that. So that's handled on another screen. This screen is probably the most important. This is where you're going to define where your endpoint lives. So Alexa takes the request from your device. The device goes up into the cloud. But once it's there, something needs to handle it. And you could either build your own endpoint, run it on your own server. That's okay as well. That would be the HTTPS option. Or you could quite easily make use of AWS Lambda, and that's what I've done in the example you'll see today. That's a very, very basic event that you'll see come into the Lambda. Nothing really too interesting there, but this is more interesting. So this is the actual response that we then give back to the Alexa-based device. So this is a real example of the custom skill that I built. So you can see here, there's two key parts to it, I'd have said. The first part being the card. So the card is, I guess if you have the Alexa app installed on your phone, when you interact with Alexa, not only do you get the audible feedback, but you also get some visual feedback as well in the actual app itself. So the data for the card powers that. And then the most important bit is the output speech. We can either configure it with plain text or we can use SSML. In this example, I've used SSML. I didn't actually need to, but I just did it for kicks. So I'm going to begin to try and tie it all up a little bit now. So that's all good. We know about Alexa. We know that we can hook it up to AWS Lambda. But the next thing is we probably want to think about what does that Lambda itself look like? What code should power that Lambda? So maybe we would consider using PHP. Reasons why you might want to use PHP, because it is not that simple, is perhaps maybe you want to get good code reuse out of this process. So, for example, if you've got some key libraries that you've already built up, and you don't really fancy porting them across to JavaScript or Python or something like that, maybe you don't need to. Maybe you can continue using PHP. Also, maybe you're just generally more comfortable in PHP. It's not so bad. But normally when we're thinking about PHP, we're thinking about sequential code. Generally, that's what PHP looks like. It's synchronous, sequential code. But in the environment where we're now talking about that every millisecond counts, that every, potentially you're going to be billed every 100 milliseconds. That's a really important difference when you're considering how to build your functions or your application. So performance is absolutely critical, which is why you might want to consider how you can bake in a little bit more asynchronous features into your PHP code. You can do that through a number of ways, depending on the type of blocking operations that you're looking to somewhat tame. There's good 3 at least, but I know there's more that spring to mind. So one is an extension called pthreads. Don't know if anyone in the audience has used that before. There's also PCNTL fork, and which is, I believe, a library. May have got that wrong. I think I have got that wrong. And then there's also, I think, more recently, a library called React PHP, which brings the idea of an event loop to PHP land. So that's quite an interesting concept. But today I'm going to focus more on some real simple changes that affects a very common use case, and it's easy to do. So a blocking operation, that could be a synchronous HTTP call. I'm sure this accounts for probably most blocking operations in PHP land. In this example, so we're using Guzzle, Guzzle 6. I'm sure some of you will be familiar with that. It's the most popular HTTP library. In this example, this is going to be slow. So if this is running on, say, Lambda, this is going to cost some money, depending on how many client or @co codes, as I've got in there. Depending on how many of those we've got, that could be a very expensive function, because it's going to make the request, hang around, okay, it's done, right. Next iteration of the loop, make the request, hang around, okay, and so on. You get the idea. But Guzzle 6 brings some interesting features that are very easy to use. So we should use them, really, especially in the context of serverless. It just makes sense. So you see here this, instead of doing a client request, we've now opted to instead use request async. And by doing that, it does 2 key things. One, it makes use of curl multi, which allows concurrent requests. And then the second thing is, instead of returning these responses in the usual way that would be in a synchronous fashion, instead it's returning promises. So I don't know how many of you in the audience are familiar with promises, but they've been around for a while, especially in like JavaScript land. They're very popular over the past few years. There is somewhat of a concept of promises that Guzzle brings to the table. So what this code is actually doing is saying that for each request, just immediately bring me back a promise. So that's very fast. But then the next bit is saying, okay, so once all of these promises resolve, then perform this callback. And if you're able to do it this way, you will make significant improvements in execution time with very, very little effort. It's just a really brief example. This is an actual use case of the function that I built. So this bus timetables function, I did a comparison of using one over the other, even just with two requests, two HTTP requests. It's not a lot, but already we're seeing savings of sometimes over a third of the execution time just by changing that out. So it's a pretty cool thing. Okay, so I did mention that PHP is not supported on AWS Lambda. So this is where it's going to start to get a little bit more interesting, I think. I hope. Okay, so I'm going to enable Alexa. Yeah, that's definitely enabled. Okay, cool. So if I drop that now. I'll just switch my screen. Okay, cool. So what I'm going to attempt to do is I want to make a change. Well, first of all, I want to show you the function that I've built and demonstrate what it does. So very simple function. If I invoke it, if I just open the skill, it immediately gives me back the three nearest buses and their times for a number of configured bus stops. So I've configured two separate bus stops. They'll then, using the transport API that I'm using, that will mean it's two separate HTTP requests. So I'll try use that now, and it could well be very embarrassing for me when it doesn't work. Okay, so Alexa, open bus timetable. Okay, that's not bad, right? That's made in that time. That's felt pretty quick. In that time, it's made two separate HTTP requests and got all the way back to me and gave me the audible feedback. Sweet. Okay. But I'm a terrible liar. So I must prove to you that that's real. Okay. So what I'm going to do now is I'm going to make a change to the code in this function, and I'm going to deploy it. And then we're going to do it again, and it better give me the changes I make. Okay. So yes, so in this part of the function, the application, what it does is it takes a list of bus objects and it then converts that into a response that Alexa can, that it knows what to do with. So it was that big blob of JSON way back on that on the slides. So it does that here. It iterates over the bus objects, takes out the information and formats it in a way that this Alexa can understand. What I'll do is I'll just prepend that response with just a very simple message. So bus times for Leeds PHP. Classic. Okay. Then what I'm going to do is, because I'm a cowboy developer, I'm just going to deploy it straight away. Okay, so this is serverless framework in action. Oh, it isn't. Oh, yeah, it is. Yeah. Sorry, I didn't realize you can't see that. Okay, is that a little bit better? Okay. So just by running that very, very simple command, it's grabbed all of the necessary files, chucked it in a zip, and then it's going to bung that up to S3, and I should, the next time I use Alexa, I should see or hear that difference that I've just made. And because I'm feeling more sensible, I'm going to test that actually that change did or had the desired effect that I wanted. So I'm going to run the function locally. Okay, cool. So you can see there in the SSML, you can see that pre-appended string that I just placed in. So bus times for each PHP. So locally, it seems to be working as we expect it. But all I've done is show you PHP, and I just told you that it doesn't run in AWS Lambda. So how's this even working? Okay, cover your eyes. So basically, it's doing it through Node.js. Within Node.js, we have a somewhat simple script that spawns a child process that allows PHP to run within AWS Lambda. So what we actually have locally is a PHP binary that we've built specifically for Amazon Linux. And we've built that, we've compiled that. All we need to do now is, along with all the other code, just chuck it up to AWS Lambda. And it should mean that we can actually make use of that PHP binary via Node.js. It feels filthy. But I am led to believe that the Pythonistas, is it? I think that's the word. Is that a collective? Anyway, whatever. They were doing this stuff before it was cool. So Python wasn't actually supported initially on AWS Lambda. They were resorting to this sort of stuff. So yeah, there's precedent there. The other thing I think I'll show you is that entry point for the function. So we're saying here that we want to spawn a child process, and an argument to PHP will be index.php. Okay, so let's take a look at that. So this is really the first bit of code, PHP code, that the function will start to execute. So very, well, somewhat simple stuff. So this first bit, I'm just making use of some envars. So locally, I've got an env file, and if I make use of this library, sorry, I'll just increase the, do that. How do you increase the font size or zoom in PHP Storm? I've forgotten. Any takers? Ah? Yeah, I thought that. With control command? Okay. That there. So yeah, making use of the .env library, it's quite cool. It just means that I can place a .env file in the function or the repo for that function and not actually commit those secrets into Git. And then I make use of those envars for various things, like, for example, credentials for the Transport API, which is an important piece in this puzzle. Yeah, so this Transport API class that I've just quickly knocked together, what it does is when we call this fetch next buses method on it, it will bring us back some promises. So just like we saw in that slide earlier, we're now dealing with promises, and we get the benefits of async. And then once the promises, or all of the promises, have resolved, it goes through and does some stuff. So take the response, turn it into some actual usable entities. Then we want to sort those entities. So we want to sort all of the bus times, the buses by the bus time. Then we want to limit the amount of buses that we serve back to the user. So you'll see there I'm only going to serve back 3 of those buses that are relevant. And then in this bit, I map that list of buses back into a response that Alexa can handle. And that's the first class that I showed you, and we made that amendment. Okay, so now comes for the moment of truth. Alexa, open bus timetable.
Bus times for Leeds BHP.
Hey.
2024.
Okay, it worked. So it really is that simple. Okay, so we're going back into the slides. Okay, so to wrap it up, I've talked a lot about the interesting things, the good things. I've glossed over the not so good things. They might include, so you need to be wary of this. So don't just think that this is the thing that will solve all your problems. As with anything, your mileage may vary. Some key things that I'll call out are you want to be aware that Lambda is probably not so great for long running tasks, so tasks that take beyond 5 minutes. It's specifically, I think, built to time out after, I think it's a hard limit of 5 minutes. Another thing to watch out for is you have, because it is serverless and you're kind of taking your hands away from the management side of it, and you don't, I guess, get that element of being able to fine tune it. So these functions are configured with memory, and that's really the only control that you get. With memory, they have respective CPUs to that. So if you want more or bigger CPUs, then you've actually also got to increase the memory size and that sort of thing. So be aware of that. A big thing to watch out for is the cold execution times that you can encounter with AWS Lambda. Not just AWS Lambda, but probably other providers as well. So if your app or your function is not being used for a long time, what actually happens is your function will get removed from the server or the container that it's running. The next time it gets invoked, AWS will actually pull again your archive from S3. It will unzip everything and then load it back into memory. So there is actually a cost to that. It can be somewhat small cost depending on the runtime, but be aware of that. There are ways to get around that, which is a thing. You can use scheduled events. So this sort of thing anecdotally happens potentially around 10 minutes. So if you wanted to avoid cold execution times completely, then one way around that would just make sure that your function is being called within that 10-minute time period. I think it's a little bit hacky, but if you need to do that, you can do that. Also, this is probably not the thing for you if your application basically has no idle time. So if it's in constant use, this model probably is not the best for you. Better suits applications that do have periods of idle time, because then you are literally only paying for the times that you do use it, and that's where the big cost savings are made. Yeah, maybe don't use PHP in AWS Lambda. It's totally up to you, but honestly, I just find it so much easier to use JavaScript. So it's totally up to you, but just don't think that because AWS Lambda doesn't support it means that you can't do serverless, and yeah, life isn't good anymore. It's not like that. You can work around it, but also consider that there are other providers as well. It's not just AWS. I think is it Azure Cloud Functions? They support PHP as a first-class citizen, so maybe consider just a different provider. Also, it's quite a different. Well, firstly, it's definitely a different architecture, a different model, um, but also it's a different workflow, I think, and you will need to get used to that. And I think functions as a service are maturing. So we've got big players in the market. They're investing a lot in this idea, and the benefits to it, I think, are quite compelling. So yeah, I think it is here to stay, and I think you should maybe give it a try. And that's it. So yeah, thanks everyone. I think we may have time for a couple of questions. Any questions? Yeah, awful. Horrendous. Yeah, so you will be largely at the mercy of the logs. Yeah, so you'll be spending a lot of your time in CloudWatch, I'd have thought, finding out what the hell is going on. Yeah, yeah. So as I say, brand new workflow, lots of stuff to learn. That was my taking on it anyway. Someone else may think it's an absolute dream. I don't know. Okay. Just out of my curiosity, out of the audience, raise your hands if you've worked with AWS Lambda before. Okay, cool. Hope. Okay, let's do it. Thanks, everyone.